Right, so what we're going to do is put some of those rules in practice. We've got some pretty intense looking algebraic expressions here, and we want to just use a bunch of those simplification rules to try to break these things down into nicer looking things. Yeah, for all of these it says expand and simplify. So remember what this essentially means for us, particularly that expand part, is make sure that you want every logarithm to have as little inside as possible. So it might mean making more logarithms. More small logarithms are better than one big one. So for example, the first one, we've got this log base 3 of 9 to the xy. So I think the first rule, actually what I might do here is write out those three main rules. So rule 1, we have log base c ab equals log base c a plus log base c b. Just so I can refer to these. Number 2 is log base c a over b is subtraction. And the last one, log base c a to the b, is b log base c a. So those are the three main rules. So for the first one, what you hopefully can see there is that there's a big division taking place. So I'm going to use that to apply rule number 2. And so what I'll get is log base 3 of 9x minus log base 3 of y. And then hopefully you can also see that we have multiplication there on the 9 and the x. So that tells me to use rule 1. And so this will give me log base 3 of 9 plus log base 3 of x, and then minus log base 3 of y. So if you're paying attention to what we see in this section here, you can see that the terms that are being added, so like you don't have a plus out front of the first term, but it is an additive term. The additive terms come from the top. And the subtracted terms, subtractive, I'm not sure what the right terminology there would be, and the subtracted terms come from the bottom. So in the future, I'm going to do that in kind of one step. So if you look at, for example, number C, or letter C, we have those 4 objects there, 32, a cubed, c squared, and root b. I'm going to split all that up in one go because I know the top things are going to be added and the bottom things are going to be subtracted. But for right now, I'm still going to clean this up. The only other thing I can do here is simplify this. 9 is 3 squared. So I can actually just reduce that to 2. So that would be 2 plus log base 3 of x minus log base 3 of y. And that would be my finished result there for that first one. You can see the insides. The inside of the first logarithm there is just x. Right? I can't break that down any further. And the inside of the other logarithm is just y. I cannot make that any simpler. So it is fully simplified. Okay, so for b, I've got log base 11 of 7 times x minus 1. I've got this multiplication. That's going to allow me to apply rule 1. So I have log base 11 of 7 plus log base 11 of x minus 1. And log base 11 of 7, that's not going to reduce any further. 7 is not a power of 11, so that is basically done. And be very careful on the second one. There's no rule for dealing with addition or subtraction inside of a logarithm. So this is not the same thing as log base 11 of x minus log base 11 of 1. All right, that's not the same thing. I'm missing the word same. right? That would actually just be log base 11 of x, because you could recombine them using that second rule, and that is not what we have here. So there's no rule for splitting this up. There's no rule for addition or subtraction in a log. So we're actually done. This is as simple as this one gets. So that one's done. So yeah, so C, I was mentioning this. I'm just going to jump ahead and follow what I was doing on the left there. And so we've got the top terms and the bottom terms. So I'll have log base 4 from the top. I'll get the things that multiply through the top. So those two factors are on the top. They're going to become positive terms in my expression. And then we've got the ones on the bottom are going to be negative. Because they're on the bottom. So we should get something that looks like that. And now what I'm going to do is apply the power rules on a couple of them. So that square root b, this is the same thing as just writing b to the half, if you remember your powers. So if I write it like that, that's going to allow me to just apply the power rule across the board here. And pull all of those out. I'm going to deal with that log base 4 of 32 in a second. I'll have plus 3 log base 4 of A, minus 2 log base 4 of C, and then minus a half log base 4 of B. And then just to deal with this guy here, the log base 4 of 32, remember that this is basically your answer to the equation x equals log base 4 of 32, means 4 to the x is 32, and that is 2 to the 2x, right? Because 4 is 2 squared is 2 to the 5, so x is 5 over 2. So that's how we can solve that. It's a little tedious. We'll get a shortcut in a second if you don't like this, but we should just get 5 over 2. And again, that's keeping in line with this philosophy of making as little in the log as possible. If I can simplify it, I can actually get rid of the log, which is simple. So that's what we usually want to do there. And nothing else changes because the insides of everything else are just pretty much single objects. And so we should get this big expression there. All right, finally, this last one, log base 2 of x cubed minus 2x squared. So yeah, what we're probably going to want to do here is do a little bit of factoring. So again, we cannot split up that subtraction. So we can't do anything with that just yet. So generally, that's kind of bad. What we can do, though, is factor. I can actually factor x squared from both of those terms. So I get log base 2 of x squared times x minus 2. And now I should be able to actually use that product rule. And yes, that's rule number 1. And so I have log base 2 of x squared plus log base 2 of x minus 2. I can't do anything with x minus 2. Again, there's nothing I can do with that subtraction, but I can pull the 2 out from x squared, and that will be it. So 2 log 2 of x plus log 2 of x minus 2. And so yeah, so that's about it that you'll see as far as expanding and simplifying. So then the next question we would ask is, now how do we reverse this action? The reasons why you might want to expand and simplify, I think actually maybe D might be a pretty good explanation as to why you might want to do it. I showed you actually in one of the other videos a graph of a logarithm where the inside was like a parabola, and the graph was a little bit hard to follow. Maybe you don't see where it came from. So yeah, if you're looking at this function here and trying to figure out what the graph of this looks like, that would be very difficult. However, we do have an idea of what these two graphs on the bottom, the log x and the log x minus 2, well, we can figure out what log 2 of x is. The other one is just a shift of that, and then this will just be a stretch of the log 2x. And we also talked a little bit about how we combine graphs by adding it. We just kind of add points, the heights of the points together. So we could probably actually graph this thing on the bottom using a better approach than just plotting a bunch of points. We could actually just kind of sketch one graph, sketch the other graph, add them together. At the very least, we have a better idea of what it's going to look like than we would maybe this initial graph at the top here. So simplify just means it's a lot easier for you to have an idea of what's going on, basically.